All right, let's talk about a word that, might give you some high school flashbacks: trigonometry. But forget all that. We're going to treat it like a kind of mathematical superpower, a tool for seeing and measuring the world in a completely new way.
I mean, really think about it. How on earth do you figure out the height of a massive skyscraper without actually climbing it? Or the distance to a star? Heck, even just the height of a tall tree in your backyard. This is the exact kind of problem that trigonometry was born to solve.
And this isn't just some abstract math problem, Trigonometry is like the hidden engine behind so much of our world. It's used in architecture to make sure buildings are safe and sound. It literally powers the GPS on your phone, and it helps astronomers map out the entire cosmos. It is everywhere.
Okay, so where do we even begin? Well, it all starts with the blueprint. The entire field of trigonometry, literally all of it, is built on one simple, super powerful shape: the right-angled triangle. If you can understand its three key sides, you've taken the first step to unlocking everything else.
First up, you've got the big boss, the hypotenuse. It's always the longest side, and here's the easy way to spot it. It's always sitting directly across from that perfect 90-degree corner. Its job never changes.
Next, we have the opposite side. And here's where it gets kind of interesting. Its name actually depends on your point of view. It's always the side that's directly across from whatever angle we're focused on, that little Greek symbol we call theta.
And that leaves us with the adjacent side. Adjacent is just a fancy word for next to. So this is the side that's touching our angle, our theta, but, and this is key, it's not the hypotenuse. And just like that, we have our complete blueprint.
Okay, so we've got the blueprint down, but a blueprint's no good without some tools, right? Well, that's where these three fundamental ratios come in. They are the essential tools that let us work with the triangle.
And here they are, the stars of the show: sine, cosine, and tangent. Now, don't let the names weird you out. They're just labels for a relationship. Like sine, it's just a shortcut for saying the length of the opposite side divided by the length of the hypotenuse. That's all it is.
So how in the world do you keep these straight? Easy. There's this legendary little phrase, so, ka, toa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, ka, toa.
Seriously, it's a lifesaver.
Now, you should know there are three other ratios: cosecant, secant, and cotangent. But the good news? They're literally just the flipped versions of the main three we just learned. For today, if you just remember SOHCAHTOA, you've got the whole core toolkit you need.
All right, let's move on to some of the fundamental rules of the game. And I want you to think of this less like stuff you have to memorize and more like an official cheat sheet that brilliant people figured out to make our lives way, way easier.
Okay, here it is. This is probably the most famous equation, the biggest celebrity in all of trigonometry. It's called the Pythagorean identity. So the sine of an angle squared plus the cosine of that same angle squared, what does it always equal?
1. Yep, just 1. It's kind of beautiful, right? It doesn't matter if the angle is 10 degrees or 80 degrees or anything in between. This incredibly simple, elegant relationship is a true cornerstone of trigonometry, and it's a direct result of the Pythagorean theorem.
And from that one big rule, we get two others for our cheat sheet. They connect tangent with secant and cotangent with cosecant. These are just really useful shortcuts to have in your back pocket when you're solving problems.
And the last thing for our cheat sheet, this table. Now, for some really common angles like 30, 45, and 60 degrees, we already know the exact answers. You don't even need a calculator. What's cool is you can see the pattern, right? As the angle gets bigger, the sine value goes up while the cosine value goes down.
Okay, we've got our blueprint, we've got our tools, we've got our cheat sheet. Now it's time for the fun part. Let's actually put this stuff to work and solve that problem from the beginning. Let's figure out how tall that tree is.
And you know what? It's way simpler than you might think. Step 1. You just walk a certain distance from the tree. That measurement, that's your adjacent side. Step 2. You use a simple tool. Even your phone has apps for this. To measure the angle from the ground to the very top of the tree, that's your theta. So, you know the adjacent side, and you want to find the opposite side, which is the tree's height. Which tool uses opposite and adjacent? Tangent. A tiny bit of math, and boom! You just measured something you couldn't possibly reach.
So, when you boil it all down, here's the crucial point. It all comes back to this one simple idea. Trigonometry isn't just about numbers, it's the study of relationships. It's like a special language that perfectly describes how angles and lengths in a right-angled triangle are forever linked together.
So yeah, it's pretty wild that a simple triangle can become this powerful lens we use to measure the world around us. It just goes to show there are these amazing, fundamental patterns woven into the fabric of reality, often hiding in plain sight. And it really makes you wonder, doesn't it? What other invisible patterns are out there, just waiting for us to find the right key to unlock them?